Hello, and welcome to our program, Astronomy for Everyone. The topic for this month's show is the Antikythera Mechanism. What's that? Well, it's an ancient analog computer built around 100 BCE, give or take 50 years, and it was constructed to be able to calculate astronomical events such as eclipses, also to help in locating the stars and planets, the constellations as well, and also to help regulate the interval between the Olympic Games. Now, the mechanism was found back in April of 1900 by a group of Greek sponge divers working off the coast of Point Gulfadia, which is located on Antikythera Island. And that's located in the Aegean Sea, not too far off the coast of Crete. Now, the shipwreck was located in about 145 feet of water, and the mechanism was found amongst a number of items, including pottery, statues, glassware, and even coins that were found subsequently later by Jacques Cousteau himself. And these coins were dated to somewhere between 76 and 67 BCE. Now, it's unclear whether the shipwreck was Greek or Roman. If it was Greek, was it transporting the mechanism along with other objects from one city to another? Or if it was a Roman wreck, was the mechanism, along with these other items, part of a bounty of war that would have been returning to Rome? Now, the mechanism itself was a bronze gear assembly that was contained inside of a wooden box. And the box had a door on the front and a door on the back, which also served to be the owner's manual, if you will. They found pieces of those doors, and there were some inscriptions as to the use of the mechanism. Now, it was originally discovered as one encrusted lump, and it was taken along with those other items to the Greek National Museum of Archaeology in Athens, where it was promptly ignored for 2 years. The curators were more interested in the statues. And because of a lack of proper conservation by the curators, as the piece dried out, it broke into 3 pieces. Now, we know that this mechanism is of Greek origin, mainly because all of the inscriptions that have been found on it are in the Greek language. Now, in this one image here, you can see a man holding the largest piece of the mechanism right there, and the person's hand can sort of give you a sense of the scale of this piece. The box that it was in measured at about 13.5 inches by 7 inches by 3.5 inches thick. So not a huge thing, but you can see it right there. Now, in the X-ray image, you can really see the complex workings of the mechanism, and especially the large gear. It's sort of a 4-spoked affair. You can see it clearly there in the image. This is about 5.5 inches in diameter and originally contained 223 teeth, which were all cut by hand. And if any of you are tool and die makers, you can understand just what exacting type of work that can be, especially 2,000 years ago. Now, one of the burning questions, I guess, where was it made? It's got Greek words and symbols on it. Well, nobody knows for sure, since we found it down at the bottom of the ocean, but 3 possible locations have been put forward. The first say that it was built on the Isle of Rhodes in the Mediterranean near Greece. This was the home of Hipparchus, a great Greek mathematician and astronomer who lived roughly around the time that they think the mechanism was built. Second place would be Syracuse, a Greek colony on the island of Sicily, also located in the Mediterranean off the foot of the Italian peninsula. This was the home of Archimedes. Now, some of the inscriptions and notations on the mechanism relate to Corinth in Greece, and Syracuse was a colony of Corinth. Now, the third possible location would be Pergamon. This was an ancient Greek city, which is actually located in the modern-day country of Turkey, about 16 miles off the coast. This city was the site of a great library of art and science, and it was so great and so well known that it was second only to the great library in Alexandria. Now, there have been many additional pieces found since the discovery back in 1900, and all of these pieces are held at the Greek National Museum of Archaeology in Athens. We're going to take a real quick break here in our presentation. If you have a question about the Antikythera mechanism or any other astronomy-related topic, send us an email. We always look forward to receiving those. The address, as always, is at the bottom of your screen. And right after Term of the Month with Stephen, we'll be back with more on the Antikythera mechanism.
Thanks, Don. The term of the month for August 2015 is SETI, the Search for Extraterrestrial Intelligence. In July of 2015, Dr. Stephen Hawking and Russian billionaire Yuri Milner and the SETI Institute announced a $100 million program called Breakthrough Initiatives. Now, SETI, the Search for Extraterrestrial Intelligence, is conducted by radio, here with the Arecibo radio dish, the largest single-dish radio receiver in the world. Using radio to try to listen to planets around other stars started really a long time ago. The first experiment that was documented was in 1896 when Nikola Tesla aimed his apparatus at Mars to try to find signals from Martians. He was unsuccessful. In 1960, Frank Drake used the Green Bank telescope in West Virginia to look at two sun-like stars, Tau Ceti and Epsilon Eridani. He had a one-channel radio receiver, and he was looking at the narrow spectrum right around what they call the water hole. It's where you can hear water sort of vibrate, if you will, in radio. These days at Arecibo, for example, many channels are used, and lots of computation is required in order to analyze the signals. And you can participate using the SETI at Home program. Look up BOINC, B-O-I-N-C, on the internet. There's also optical SETI, which was pioneered at Harvard. You use a normal telescope, optical telescope, and you use a special camera which is looking for very short pulses. You can use a modest amount of power in a laser to generate pulses that will outshine your host star. So this is a promising sort of approach. This new initiative advances radio and optical SETI. So the term of the month for August 2015 is SETI.
Thanks, Stephen. Welcome back to the program. This month's topic is the Antikythera Mechanism. It's an ancient analog computer used to calculate astronomical events. Now, we've talked about where it was found and size and possible usages. We're going to get into the basic operation of this mechanism. It was comprised of 30 gears that were turned by a hand crank, which is lost. They have no idea where it is. This hand crank was connected to a shaft, and the shaft was attached to a crown gear, master gear, kind of, if you will. And this crown gear then, in turn, operated all of the other gears to perform the various function of the mechanism. Now, in this first image, which shows us the front, there are two rings, two concentric rings. The outer ring identifies the ecliptic, and it also shows the 365-day Egyptian calendar. Now, that ring was adjustable to make up for that quarter day. They were aware of it even back then. The names across the outer ring are the names of the Egyptian months, but they're written in Greek characters. Now, the inner ring designates the Greek zodiac, and it has the markings of degrees on it, the 360 degrees that the Greeks received this knowledge from the Babylonians, the ones who devised the 360-degree circle. And in addition to that, there was also a place to show the sun, the moon, and the 5 planets that were known to the ancient peoples. Now, those indicators have broken off or been lost long ago, but there's enough there to indicate that those were there. In addition to this, there are notations noting the risings of the constellation Taurus, the bright stars Vega, Altair, and Arcturus, and also, interestingly enough, the Pleiades, or the Seven Sisters, is also noted. Many ancient cultures, the Greeks included, used the rising of the Pleiades as sort of a marker to when to begin their planting. Our next image shows us the rear of the mechanism. Now, this is obviously a modern recreation, and it displays the various cycles that were calculated on this part of the mechanism. 2 cycles in particular. One is known as the Metonic cycle. It's a 19-year period that lines up both solar years and lunar months. In a 19-year period, they both end up to be exactly the same. The second cycle is known as the Saros cycle, and this helps calculate the timing between solar and lunar eclipses over a period of time. Now, it also helped with the timing of the Olympic Games, and you can see that small dial just to the right there that helped coordinate those. There were several Olympic Games that were held, not just the ones at Olympus, but this also helped keep track of those as well. And in addition, the mechanism was aware of both the tropical, that's the solar year, and also it had the correct orbital period of 27.32 days. That's the length of time it takes the moon to orbit the Earth. The phases of the moon, however, a little bit different story. Those are 29 and a half. One of the big questions about this mechanism is, are there others? Well, at this point, we don't know. It's the only one that we've been able to find so far. It's interesting to note, though, that as they study the mechanism, especially through X-ray, that they don't see any modifications. There are no extra holes, patches, or other parts of it that don't seem to do anything. So this doesn't appear like this was the first one. I mean, to try to build something of this complexity 2,000 years ago and get it exactly right the first time? Probably not. Was there just one maker who made this mechanism and others? Maybe. Was this maker one in a series of makers that built these machines, which then obviously there would be more somewhere, perhaps. Now, it's interesting to note, too, that the complexity of the gearing in this mechanism is as complex as we find in European clocks that weren't built until the 14th century AD, 14 to 1500 years later. Also, there is no reference made in any of the literature that has come down to us about this mechanism or any others. So, are there more? I guess time will tell. Another interesting question is, does the mechanism support either the geocentric or the heliocentric view of the universe? Geocentric is, of course, Earth-centered. Heliocentric, centered on the sun. Of course, this was a big debate going back even to ancient times and moving forward even through the Dark and Middle Ages up until the last couple of centuries, especially since Copernicus and Galileo. The purpose of the machine is not to get into a theological discussion about a particular system over another. It was designed to show objects on a sphere, the celestial sphere, the sky above our heads, and to show where certain objects would be at a certain time, to make predictions of these eclipses and other events. So, does it really matter whether the mechanism supports one or the other? I mean, we know that the Earth is not the center of the solar system. It's the sun, of course. But yet, as amateur astronomers, we set our scopes up to view the celestial sphere based upon where we are on Earth using a geocentric setup. So that question is really a moot point, in my mind anyway. What you might think is, well, certainly up to you, of course. So what we're going to do to finish up with this topic of the mechanism is show you about a 3-minute video from YouTube. We'll give them props for that, of course. This shows a replica of the mechanism that has been built out of Legos. This is a great video, and I couldn't explain better in 3 hours what this video does in 3 minutes. So let's have a look. I guess we can't hear the music out here. And there it is. Pretty interesting, I think. I hope you've enjoyed this presentation. To learn more, there's plenty of information on the World Wide Web, of course, and books in the library. Let's not forget about them. If you'd like to check out our club website, you can always do that. We're glad to have folks take a look at that. You can find some information, too, about Astronomy for Everyone there. Coming up next, before we go to Stephen with What's Up in Our Night Sky, I want to take a couple of minutes to inform you about the upcoming Astronomy at the Beach. Yes, it's that time again. It's coming up in September, Friday and Saturday, September 25th and 26th. It's the last weekend of the month. This is, I believe, the 19th or the 20th annual event. As always, it's being held at Kensington Metro Park's Maple Beach location. Kensington Metro Park is located off I-96 near Milford. We'll have the telescopes from the many amateur astronomy clubs located here in southeast Michigan. They will be on the beach, and the owners of those scopes will be ready to show you a variety of different astronomical objects that will be visible that night. Saturn will be one of them, and that's always a great thing to take a look at in the telescope, along with the moon and other objects as well. As always, the only sure expense that you're going to have for this event will be the vehicle entry permit, unless, of course, you have the annual permit, and then you're all set. The astronomy talks, our main speaker, along with talks by some of the members of the area astronomy clubs, along with the telescopes, the Michigan Science Center's Star Lab Portable Planetarium, that is all free. Now, we will have astronomy vendors there selling a variety of astronomy-related products that you can peruse and, of course, buy if you want to. And if you get hungry, there'll be food there available for purchase as well. This is a very family-oriented event. Also, students interested in astronomy, moms and dads, the kids, extra credit for a school project, even though school has just started. It's a two-night event. It's held clear or cloudy on those 2 nights. The event begins at 6 p.m. and runs till midnight. So we hope to see you there again, September 25th and 26th, Astronomy at the Beach. And now, here's Stephen with What's Up.
Thanks, Don. What's up in the night sky for August 2015? You have to see the Perseid meteor shower this year. August 12th is the peak of the shower. Days before and after should also be good, but certainly the peak on the 12th. The moon is new, so the moon is not an issue. It rises at dawn, so you can watch meteors all night if you want. So, look for dark skies, get away from the city, dress warm, look up, for example, take a blanket and lie down on it looking straight up. You want to see as much of the sky as you can see. Bring bug spray, food, drinks, but alcohol diminishes your night vision, and the meteors will streak by. At the beginning of the month, the sun rises at 6:25 in the morning, and by the end of the month it rises at 6:57 in the morning, so it gets later. And at the beginning of the month the sun sets at 8:52 in the evening, and at the end of the month it sets at 8:09. So the days are getting noticeably shorter as we get farther from the summer equinox. The moon starts with a third quarter on August 6th. It's a new moon on August 14th, right near the Perseid meteor shower. The first quarter is on August 22nd, and then the full moon is on August 29th. Mercury is better at the end of the month. So this is an August 31st shot at about 8:20. So this is 15 minutes after whenever your local sunset is, and 35 minutes before Mercury sets. That's your best bet. You can kind of see the arc there. That is the orbit of Mercury if you were to see it over days. Venus is in Cancer. This is an August 31st shot at 5:53 a.m. You can see Mars as well. So Venus is in Cancer, and Mars is also in Cancer. Venus rises at 5:23. Mars rises at 4:57. So this is still before sunrise. Jupiter is at superior conjunction, so we're not going to see it. That means that it's on the other side of the sun from us. Pretty much all month it's impossible to see. On August 15th, this image of Saturn, which is in Libra, is at 10 p.m. It's a good compromise. It's dark enough, but you can see it. Saturn sets from 1:30 to 11:30 over the course of the month. Uranus and Neptune here at midnight. So Uranus in Pisces and Neptune in Aquarius. They rise 11:40 to 10:40, that sort of time of night. And we also have Vesta here. You can see down and to the right of Uranus. Pluto in Sagittarius sets at 4:30 in the morning. This is on August 15th at midnight. You can also see Ceres in the shot. New Horizons just went by Pluto, and here are some shots. So this is actually a shot of Charon, the moon of Pluto, that New Horizons took. This is Pluto and Charon in their scales. Charon is a really big moon compared to Pluto. And this is also Pluto. So this is just a little hint of what we're going to be seeing soon. We'll talk more about Pluto next month. And that's what's up in the night sky for August 2015.